Okay, this is going to be a little bit of a double lesson here. So we are covering the sine and cosine ratios today. So the past two videos, if you want to go back and watch those, we did the tangent ratio and we used it to find missing side lengths and missing angles. Today we're going to be using two new ratios, and they kind of work the same way. They're the ratios of two different side lengths, and we're going to use those to figure out side lengths and angles. So I have this already highlighted here. You can go ahead and highlight them in your notes if they're not in color yourself. But it shows how we label a triangle. So I'm just going to kind of talk you through this. So let's say we're focusing in on angle A here. Either we're given angle A or we want to find it. So we still label the side that's opposite to angle A the opposite, and the side that's adjacent to angle A adjacent. Adjacent, again, remember, means right beside. And then the hypotenuse is the longest side. So it'll always be the one that's right across from the right angle. We call that the hypotenuse. Okay, so we already had that tangent of A is opposite over adjacent. So we saw that in the first two lessons. Now we're going to add two new ratios to the mix. First is sine of A. So the full, if you spell it out, it's S-I-N-E, but S-I-N for short. And it's opposite over hypotenuse. And then cosine. So if you spell it out, it's cosine like this, but we do COS for short. So the cosine ratio is the adjacent side divided by the hypotenuse side. So we can use any of these three ratios, tangent, sine, or cosine, to determine a missing length or an angle. And it depends on which side lengths we're given. That is a lot to remember. There's three of these ratios, but there's a handy little kind of acronym that we use to remember the three different ratios here, and that's shown on the side. So we use something called SOHCAHTOA. So SOHCAHTOA. So the S, the C, and the T in SOHCAHTOA stand for sine, cos, and tan, or sine, cosine, and tangent. And then the OH, the AH, and the OA are the formulas. So notice that SOH, the O and the H tell you that it's opposite over hypotenuse. So the first letter is on top and the second letter is in the denominator on the bottom. Okay, and then next is Ka, so it would be A over H. And then Toa, O over A. So you'll probably, like on a quiz or something, I would just recommend writing SOHCAHTOA at the top of your page, and then you can remember all the formulas just like that. Okay, so let's practice using SOHCAHTOA and all these three ratios to determine missing angles, and then on the back page we're going to do missing side lengths. Okay, so here's example one. We're going to use this triangle here, and we're going to write down two ratios, and then we're going to find out what angle D is. Okay, so here's angle D. So we're focusing in on that. I'm going to use the same colors that I used above here. So the side that's opposite to angle D, I always start with that one. That's this side here. It's directly across, and we labeled that in green. So I'm going to go ahead and do that in green. My green is slightly different, but that's okay. And then the side that's right next to angle D, that's the 12. That's adjacent, and I used yellow, so I'll use yellow again. That's going to be adjacent. And then the longest side is always across from the right angle. That's 13 here from D to F, so I will label that in blue. And that's called our hypotenuse. It's the same word we used when we learned the Pythagorean theorem. Okay, so now we have all our sides labeled. That's always step number one. Step one, label your sides, always. No matter what kind of question you're doing, if you're using sine, cos, and tan ratios, you want to figure out which sides are which. Okay, so now that we have that, it says write down what sine of D is and cosine of D. So sine of D, so I'm just going to write SOHCAHTOA here, and that'll help us remember what the formula is. So no need to memorize the formulas, just memorize SOHCAHTOA and how to spell it. So S sine is followed by OH, so it's opposite over hypotenuse. So the opposite side is the 5 centimeters, and the hypotenuse is the blue side, which is 13 centimeters. So sine of D is 5 centimeters over 13 centimeters. You don't need to write the units actually, because they cancel each other out anyway, so it's just simply a number. Okay, and then we'll do the same thing with cosine of D. So cosine of D, if we look at the SOHCAHTOA formula, it's A over H. So adjacent, I'll do ADJ for short, over hypotenuse, I'll do HYP for short. So the adjacent side was the yellow side, right next to the angle, and the hypotenuse was the blue side. So if it simply asks for the ratio, sine of D or cos of D, you're just giving this fraction. You're not determining any sides or using your calculator just yet. So it'd be 12 over 13. Okay, so those are the two answers here. Okay, so then part B says use either one, and I'll show you both actually, to calculate the angle D. So I'll use sine first. So if we know that sine of D is 5 over 13, if we want to calculate what this angle D is, we have to use the inverse sine function. Just like in lesson 1 we used the inverse tan function. So we're going to use the inverse sine function. So angle D is going to be sine minus 1, which means inverse sine function of 5 over 13. So when you type that into your calculator, so for my calculator, I have to type 5 divided by 13 first, but you might have to type tan first. It just depends on your calculator. So I just use division here, 5 divided by 13, and then I'm going to click my trig button. You will probably have to press shift or second, and then find the sine minus 1, so the inverse sine button, and it calculates that angle for you. So 22.6, where it says to the nearest degree, so 23 degrees. So we can write angle D is approximately 23 degrees. I'm going to use the cosine to show you that you would get the exact same answer. So it actually doesn't matter which ratio. You can also use the tangent ratio. You should still get the same answer no matter what. So it's a good way to check your work if you have some extra time on a quiz or something. Because sometimes it's easy to type these in wrong in your calculator or make an error that way. Okay, so 12 divided by 13, and this time I'm going to use the cosine inverse button. Exact same decimal here, so about 23 degrees. Cos minus 1, 12 over 13. And if you wanted to use the tan ratio, it would be opposite over adjacent, so 5 over 12. And you would see it would be the exact same thing also. Okay. Example 2, calculate angle G and angle H to the nearest tenth of a degree. So this time it doesn't tell you which ratio to use, so it's totally up to you. So let's the first step is always, I'm going to write it out again just because it's so important. You want to label the triangle, the sides. Okay, so we're talking about angle G here. We'll start with that. So I'm going to just circle it. So everything that we label is going to be based on angle G. So this side here that's directly across is going to be the opposite side. We don't happen to know that length in this one. And then the one right next door is the adjacent. And then the longest side, which is on the bottom here, is the hypotenuse. So I'm just going to go ahead and use my labels again. So yellow was my adjacent color. My opposite color was green. And then my hypotenuse color was blue. Okay, so we have to be smart about this and strategic. So we have to use a ratio that makes the most sense. So I'm going to write out SOHCAHTOA. And we don't want to use a ratio where we don't have one of the side lengths, because then we won't be able to use our calculator. So we are going to use the ratio that involves the hypotenuse and the adjacent, because those are the side lengths we actually have. We're not going to use one of the ratios that involves the opposite side because we don't have that side length. So we are going to use the cosine ratio since we have the adjacent and the hypotenuse, right? So we're going to write this out. Cosine of angle G is adjacent, so 6 over hypotenuse, so 14. And you know the order because it's in SOHCAHTOA. Okay, and then to find angle G, we are just going to type the inverse cosine function into our calculator. So you always use the inverse cosine function when you're finding an angle. So for my calculator, I need to type 6 divided by 14 first, and then I click the inverse cosine, but you may have to do the opposite. So this is about, so it's nearest tenth, so 64.6. So that's angle G. I'm going to label it here 64.6 degrees. Now for angle H, you can go through that whole process again and use all the trig ratios, but the easier method, I'm just going to do like a little dotted line here. Angle H, just subtract from 180. We know that the angles in a triangle all add up to 180, so it's much faster to just subtract what I already have. So I already know that one of the angles is 90 and one of the angles is 64.6. So the other angle must be, so 180 minus 90, which is 90, minus 64.6. Oops, I must have typed something wrong there. 180 minus 90 minus 64.6, 25.4. I'll do a little squiggly because it's not exact. Oops, sometimes I write numbers in the opposite order. 25.4 degrees. There we go. So there's angle H. I'll label it on here. So that's just a summary of how to, I'm just going to scroll back up for a second. So we defined all three ratios. We talked about SOHCAHTOA, and then we did a couple of examples where we used our ratios to determine missing angles. So on the back side, we're going to use the ratio to determine a missing side length, and it's going to be really similar to the last lesson where we used the tangent ratio to do this, but this time we're using sine and cosine. Okay, so here it says determine the length of BC to the nearest tenth of a centimeter. Okay, so because I have angle C, that's going to be the angle that I focus on. And again, step one is always, I'm going to write it again because it's really important, label the triangle. Okay, so we want to find angle or side length BC. So I'm just going to call this X here. Okay, so let's label our sides. This is the opposite side. It's right across. This is the hypotenuse. It's the longest side. It's right across from the right angle. And this is the adjacent. So we have to be strategic. Let's look at SOHCAHTOA. The question doesn't tell us which of the three ratios to use, so we have to use our brains and think about which one is the best. So I'm just going to do some highlighting here. So the opposite side, sorry, the hypotenuse side is blue, opposite side, adjacent side is yellow, and opposite side is green. So I don't want to use any of the ones with the green opposite side. I don't want to use sine or tangent because I don't have the opposite side and I'm not trying to find it either. I do want to use the cosine ratio because I want to find the adjacent and I have the hypotenuse. So both of those side lengths are important to me, so I'm going to use that ratio. So you have to go through that process of figuring out like which one is the best to use every time. So let's write out my cosine ratio. So cosine of angle C is going to be adjacent over hypotenuse. So let's put in all the values. So cosine of 50 degrees is going to be the adjacent side. We don't know that, so I'll put X over the hypotenuse, which is 5.2 centimeters. And then we're going to use algebra to solve for the missing side. So when your unknown value is in the numerator, we can simply do the opposite of dividing to get rid of the 5.2 and isolate X. So I'm going to multiply by both sides by 5.2 centimeters. And that way they'll get canceled out on the right hand side and I'll isolate X there. So what I'll end up with is X equals 5.2 centimeters times cos of 50 degrees. And that's what I'm going to type into my calculator to solve for X. So let's clear my screen here. So I have 5.2 times, and for my calculator I have to type 50 and then the cosine, but yours might be the opposite. So I have 5.2 times cosine of 50, which is that right? How many degrees? Let me try that again. Cosine of 50. I'll try and do it in the opposite order. Maybe that's cosine of 50 times 5.2. Maybe I have to do it in that order. Yeah, there we go. Okay, so I have to take cosine of 50 and times 5.2 in the other order. My calculator is not the best. Okay, so it's about 3.3. It says nearest tenth, so x is approximately 3.3 centimeters. And don't forget your units. We're measuring length here, so the other length is in centimeters, so our length is going to be in centimeters as well. Okay, let's try one more. So you can pause the video here if you want to try it on your own, or you can do it along with me. Okay, so we are given angle E here. So that's our important angle. So everything that we label is going to be based on that. So step one is always label your triangle. So across from angle E, that's called the opposite side. This is the adjacent side here, right next to angle E. And then the longest side is the hypotenuse. And we are determining side DE. So this time we are finding the hypotenuse, which I did label in blue before. So we are finding this blue side. Okay. The other side that's going to be important this time is the side that we have the side length of, which is this green side, the opposite. So in this question, we don't so much care about the adjacent side. We care about the opposite side because we have that. And then the hypotenuse, because that's what we're trying to find, because the question is asking us to solve for DE. So I'm going to label that X. Okay, so if I write out SOHCAHTOA, I can figure out which ratio I want to use. So I don't want to use these two because both of these have the adjacent side, which I don't need in this question. I want to use this ratio here because it's got the opposite and the hypotenuse that I need. So I'm going to use the sine ratio. So sine of the angle, 55 degrees, equals the opposite side, so 6.8 centimeters, divided by the hypotenuse, which I don't have the length of. I'm trying to find that. Okay, so we can do opposite operations, or if we just remember that we switched places, these two. So essentially we're multiplying both sides by x and then dividing by sine of 55. So those two essentially just switch places. And we end up with x is 6.8 centimeters divided by sine of 55 degrees. And in my calculator, I believe I type 6.8 divided by 55 and then sine of that angle equals 8.3. So x is approximately 8.3 centimeters. I'm just going to double check that I rounded that correctly. Yeah, and then we're doing to the nearest tenth. So one decimal after, or one place after the decimal. Okay, there we go. So the hypotenuse there is 8.3 centimeters. And we have our missing side length. Okay, so that's using all three ratios now we've learned to use to find the missing side length or a missing angle.